Think styrofoam cup, and you're closer to understanding a new type of construction.
Heavy equipment is essential to keep this project pumping.
And a type of electrical wiring we haven't seen before. This hot project and more on today's Gimme Shelter.
Hello and welcome to Gimme Shelter. I'm Robin Kipp.
And hello everybody, I'm Harvey.
And today we're at what will be the new home of Bob and Tina Turk.
It's a beautiful wooded lot in Phoenix, Maryland, not far from Baltimore. It's a great site with some nice natural features to it as well. A creek flowing behind the house, some rock caves just up over the hill there.
We did mention we are very close to Baltimore. In fact, one of our homeowners, Bob, is a TV weatherman, and all his experience as a meteorologist has taught him how destructive Mother Nature can be.
In fact, it was while he was attending a hurricane conference that he first became familiar with this style of building. It makes for a very strong structure, and it's a method of building that we've not yet been able to bring to you here on Gimme Shelter.
In fact, I'm going to learn a little bit more about that. I'm going to go talk to the contractor.
Should be a great show.
Tell me about the product we're using to build this house.
This is an insulated concrete form. There's many different kinds of forms out there. This particular form is a solid wall system or solid slab. It's a 4-inch cavity with 2 pieces of EPS on each side.
EPS?
Expanded polystyrene.
Okay.
The black webs in between, these are your studs or your strapping where you can screw your studding to, or your sheetrock.
Okay.
Okay.
And then there's rebar that goes right up through here,
yes,
too.
Yes, rebar goes up through there. Rebar also goes horizontally, too. Okay.
So this is a strong structure.
Yes, it is.
And it has an R value in it, too.
Well, as this block stands right now, it has an R value of about 22. With concrete in it, concrete gives it the thermal mass. You can shoot it up to about in the high R30.
When you're working on a sloped site like this, one of your concerns, of course, is water when you get a heavy rain, such as we did last night. Now, it's made the construction site pretty much a muddy mess today. And one of your concerns, of course, building a new house is to protect the building from that kind of water damage. Around on the other side of the house, Robin is working on controlling just that exact problem.
We're at the point in construction where we're ready to waterproof our foundation walls, and that's exactly what we're going to do with Steve Chacones here. Tell me why we need to waterproof the foundation walls.
We need to protect the inside of the house from moisture damage. Waterproofing is a whole different animal than damp proofing. Damp proofing lets the penetration of water through the damp proofing product into your interior block wall, concrete wall, and or styrofoam wall. We need to educate the home public to say that they want waterproofing.
Why is that?
Well, one of the most affordable living spaces in a house is the basement. It's cheaper to finish off. It's a third of the cost of the whole house. And most small families have children or buying houses that they can finish basements off.
Nice little playroom.
Yeah.
Absolutely. Well, I see that you're cleaning off this area here. Tell me, what's our first step?
Well, we need to clean the footing off so we get good bond. When I spray, I'll spray down and onto the footing about 4 inches, so any water that comes down will roll off. I'll put a drain board on the wall, and then they will put their exterior drain tile, which is what they have here. I had to clean back because we started this job last week. That'll roll around and all the water will flow to it.
Okay, let's start.
Okay.
Okay. What we're doing is putting down a waterproofing membrane. In this case, it's called a Marcoat 5000. And what it is a polymer. It's a mix of asphalt and rubber mixed at a very high temperature and then sprayed onto these foundation walls. Now, after 1 or 2 years, your house is going to settle, and that means you could have some cracks in your foundation walls. This membrane will cover up any of those cracks to prevent any water from seeping through into your basement. Now we're going to put this aqua board into place, and Steve, if you could tell us a little bit about what the aqua board is.
The aqua board's a mineral board, mineral wool. What it does is, the first thing it does is protect my coatings, especially on a styrofoam foundation. It's very rigid coating, but if a rock were to fall, it would cut my material. On a concrete foundation or block foundation, I don't need to protect it. This adds water drainage, so any water caught in the substrate in the soil drains through the soil, hits the board, runs down to your exterior drain tile, which we'll be doing after we apply all the board.
So you have a drain tile down here that takes all the water away from the house.
Yes.
And that is crucial.
Yes.
That's exactly what we're trying to do here. Well, we do have a lot of work to do here, and later on, people are going to come in here and backfill this whole area, but we have a lot of waterproofing to do. We should get to work.
Yes.
Let's explore this basic building system a little bit further. I mean, this is pretty unique, very interesting stuff. Now, this is the basic material that you start with. This is the way it shows up on site. This is a bundle of 6 of these panels. The panels being made of styrofoam. The material almost exactly like a styrofoam cup that you'd find at home. They're about 2.5 inches thick. There's 6 of these individual pieces in that bundle here. And we're working with Roy, continuing on site here. And Roy, these they come like that, and then you sort of put them together like a puzzle.
Yes, they snap together like a Lego system. They come broken apart, 16-inch high by 48 inches long.
Okay.
And as we assemble them, we'll assemble this block right here in front of us.
All right. The one you got in front of you we'll work on?
Yes.
Now these, let me just ask a question. These are embedded in the styrofoam.
Yes, they're
right?
embedded in the styrofoam. All they're supposed to be, they're studs for your sheetrock or sheetrock or any other attachment.
So you just need enough stiffness to hold these in place until you get the concrete in, which is the real strength.
Yeah, once the concrete gets in, as long as it holds the concrete for about 15-20 minutes so the concrete would flash,
Okay.
then all this is insulation, and you're studding for your interior and exterior.
You said the concrete would flash. I haven't heard that.
Harden.
Oh, okay.
Would harden. Then we'll take another panel, bring it up to assemble more block.
Well, the stuff just snaps in place there, doesn't it?
Yes. Flip it right around. Stick it right on.
And then we do the sort of tongue and groove thing here.
Works great.
Look at that. And then how many more little of those plastic bracers do you put in?
We need 12 per block.
Okay. All right. Now we just carry this. I mean, how much could this weigh, Roy?
Weighs about 6 pounds each block.
It's amazing. So you just tap them in place like that?
Tap them in place, and as you can see, all your studs are lined up on the wall, every 8 inches on center.
All the little zigzag pattern here, make sure you're lined up side to side, laterally, so everything does line up.
Yes, it does.
Top and bottom. Now the pumper truck has arrived on site. You can probably hear it behind me. We're waiting for the concrete truck to show up because in just a little bit we're going to be ready to actually start pouring some concrete into our forms. But first, Roy, I wanted to take a look at this bracing system. Take me through this.
Well, with this bracing system, we have to place a cleat on the footing, and as we slide the piece of C-channel over top the cleat, we line it up to our stud or webs.
Right? Okay.
And we place a screw at the very top, right into the block. And we place the screw in every single block. And we do this every 6 feet. Give us a scaffold plank to walk on, and so forth.
Now you were telling me that as the pour actually begins, as we put concrete down into these hollow forms, the wall is actually leaning in just a little bit, is that right?
Leaning slightly, so it's easier to push a wall out than pull a wall in with the bracing system.
So I'll exaggerate it, but with the wall leaning back like that, you fill it with concrete.
Yes.
And then before the concrete sets, obviously you'll straighten it back up.
Straighten it back up.
Okay.
Bring it up to level.
Great.
Now we're putting up our scaffold.
Yeah, that's the thing I noticed about your system that's so cool too, is that you've got you're building the scaffold so that you can build your walls higher.
Exactly.
This is where your planks will go, so you'll walk on them.
It's one complete system.
Hey, Roy, and then the Scaffold plank just goes up there. Again, that gives us a working surface to stand on as we continue on up the wall, building the wall up to the height, right?
Exactly.
But that's the basics of our bracing system.
Exactly.
And in fact, we're going to get to the actual pouring now that another section of the house is ready for the concrete. So let's go over to Robin at the pumping truck.
We're now ready to pour concrete into our forms. The concrete truck isn't here yet, but we do have our Schwing concrete truck. I'm here with Ted Nettles, who can tell us a little bit more about how this machine works. The concrete comes in and then is poured through this hopper. What happens from there?
Concrete will come in the ready mix truck. It'll be discharged into our pump hopper. And then it goes through the pump, comes out the discharge lines, through the pipe, through the boom. And what we do when we're pouring these ICF houses is we'll put a fitting on the boom to slow the flow of the concrete down so that we can pinpoint it in the walls where we want it without a lot of force, and so you don't move the walls and everything like that.
The whole process starts with this concrete truck. The concrete rolls from that truck into the hopper and then is sent into the pipes, up through the boom, and into the walls. Now what we're looking for are 5 or 6 cubic yards. And a yard is about 3 feet by 3 feet by 3 feet. In this concrete truck, we have about 7 or 8 cubic yards. So we have more than enough. But say we ran out. Say we didn't have enough concrete in the truck. What we would do is send the boom up over the hopper, and we would circulate the concrete until the next batch of concrete arrived, and then we could continue pouring. We don't want to clog up any of the booms. Anyway, what's happening right now, we don't have to worry about any lack of concrete. It's sent right through here, the hopper, up through the boom, and over to Harvey.
Robin, this is a job, boy. If you love toys, we've got them all out here today. We've got the right pieces of equipment to get the concrete over to where we are, and we're just about to continue our pouring here. Now our pour is moved over around to this section of the wall, and we're controlling the amount of the pour, the flow rate in here, because as Roy said, a 4-inch cavity, that's the width between the styrofoam panels. A 4-inch cavity fills up pretty rapidly. Now what we're doing is we work around the wall, pouring this material in here, and we're tapping down below. Several of the guys are beating on the walls down there, basically using the sound as an indicator that it's full. Obviously, we've got to have a full wall. Now, I'm trying to keep ahead of the boom here as well. This is a crucial operation of communication between Roy here and Dan back at the truck, because Dan is really the one controlling where this boom goes, where the pipe is spitting the concrete into here. And he's feathering it very carefully, because obviously he doesn't want to knock either one of us off of the scaffolding here. Roy, is it filling up all right?
It's coming along.
Okay.
Looking good.
I don't want to
splatter.
I don't want to distract you. I know you're busy at the moment. Now, the concrete comes in various strengths, and what we're pouring here in these walls is 3,000 psi, that's pounds per square inch. That means it's a test of the strength of the concrete. It'll take 3,000 pounds per square inch before it crushes or breaks apart. And as it cures up in the walls here, it'll actually increase somewhat in that strength. Hey, Roy, about how long for this to initially set up?
This is pea gravel. It should set up approximately 30 minutes to an hour on a temperature like today.
All right. And then in about 24 hours,
it should be probably about 700 to 1,000 psi, probably
Right.
700.
and as it continues to cure, it'll increase in strength until it gets to its rated strength and maybe even a little beyond.
It's going to go beyond. If we're pouring 3,000, we should be around, after 9 months, about 5,500.
Is that right?
Yes.
That's quite a bit beyond your rating.
Yeah, it's pretty interesting.
All right, well, I'll let you keep working here because obviously we've got time constraints about moving around the perimeter of the building and keeping the concrete flowing.
We're ready to install the windows. Now, this isn't a conventional house, so there are some different rules when installing the windows. I'm here with Chad Farmer, who's bringing out this very heavy window and being a real trooper about it, too. Okay, now what is the difference between installing a window on this kind of house compared to a conventional house?
Well, typically on a conventional house, we'd have wood framing the whole way around it. We could just attach the window, you know, with an 1 1/4 roofing nail. In this case here, because we have a plastic jamb, we're going to have to run screws in to hold it in place, and until we get inside to shim it and lock it in.
Okay, you'll also notice there's no house wrap, and that's because we do have the plastic rough framing here, so we don't have to worry about that. Now, what we want to do is basically make sure it's pretty much in there,
Okay.
and then we'll make sure it's plumb.
Can you get that? Is that us there?
Yep.
All right. Just mark it here.
Make our marks.
Okay. You got the drill right there behind you then? Well, I tell you what, since I'm holding this side, you want to go ahead and run one in on yours?
Sure. Tell me about what kind of screws we're using here.
We're using a fine thread screw, and to have a little better holding power than a coarse thread screw going into this plastic. A coarse thread might have a tendency to want to bore out the hole too much and give us some slippage. All right, thank you.
And once Chad finishes up screwing this side into place, we're finished on the outside and we're going to go inside. Now we're ready to shim it up from the inside. And you're just putting it in 3 different spots here, down on the bottom. And you just want to really snug this up, don't you?
Yes, that's correct.
Now, after that is snugged up, you want to put a trim screw right in there to secure that into place.
Lock everything right there through the jamb.
Okay, and then we're ready for a styrofoam spray that we'll put in all around the edge of this window frame here so that we make sure that there's no air infiltration, so that your cold air doesn't escape out or the cold air doesn't get in during the winter. That's really important. And then after that's done, we'll put on our extension jambs, then we'll put on some decorative framing and the windows in, and it looks great. Now, if this looked pretty easy, that's because it is, and it's a good thing, too, because we have almost 50 windows to put into place.
Now, as you know, we like to talk to our homeowners to find out what their story is. But we also told you that Bob Turk is a local weatherman, and he was a little hard to catch up with. So it forced us to go to him and find him at work.
We might have a little fall, but like the next couple of days.
Tina, in the meantime, tell me, why did you decide to move?
We finally had the opportunity to build our dream home. So we wanted to use it with the best materials for the environment, because both Bob and I are very involved in making sure that we're building the new way. The House of 2000 is really what we were looking to do.
Is that right? Hi, Bob. Nice to have you join us.
Thank you, guys.
Hate to take you away from your work here.
Traditional Maryland crab feast, you know.
So Bob, I mean, this is really an interesting structure that you're using,
Yeah.
and certainly different than the average house. Tell us that about how you found
the
that.
whole thing kind of started. I attend the hurricane conferences every year, and at hurricane conferences, we talk about hurricanes. We talk about how dangerous hurricanes are and how dangerous they become, because so many people live in these hurricane areas. And what can you do to prevent yourself from your house being destroyed in a hurricane? Well, this one guy had a demonstration of these forms, these styrofoam block forms, to build houses. I said, well, that's interesting. And he was doing it in Florida. I thought, well, I stuck in the back of my mind. I kept reading about it more and more. And this was a while ago. And now there's so much more information about this insulated concrete form building structure. I said, I got to do this. I've got to do this, because you build a concrete wall like that, and that wall is going to withstand hurricane force with up to 200 miles an hour, or tornadoes or thunderstorms, which we do get in this area. So I wanted to build a strong house, which is what we're going to get with this.
Plus, it's got a lot of other interesting properties, and the insulation value.
The insulation
for it.
value is unbelievable.
Yeah.
In this climate, perhaps as high as like R50, which means your heating load here is reduced by maybe as much as 70% or more, something like that.
Tina, since this was Bob's bright idea, I mean, did you worry about building an unconventional house like this, using something new and different?
I wanted to make sure the outside was going to look nice. What was it exactly going to look like? I wanted to make sure my architect would approve it, that it is structurally exactly what they say it is, and it is. And I wanted to make sure we could afford it.
Yeah, that's true too.
Well, Bob, it was a little tough to catch up with you, but hey, look, we ended up in this great restaurant.
You left me a couple here. That's
How
good.
can we come to Baltimore?
Maryland crabs.
Not do Maryland crabs, yeah.
Easily, right? They are. Now
we're downstairs outside the basement of this house, and this is an enormous basement. It actually, square footage-wise, is about 3,400 square feet, which is a big basement, believe me. And where we are in the process now, they've just poured the floor and they're finishing it up. In fact, the guy behind me is using a power screeder. It's a power tool that's applying a finish. Now you can see that the concrete is firm enough. At this point, it's set up just enough for him to be able to walk on the surface, but it's still soft enough for the power screeder to begin to finish it off, give it a nice, smooth finish. Now, between here and the garage upstairs, which is going to get poured next, there's a total of 48 yards of concrete going in here. Timing, of course, is essential in this operation. He couldn't have started that operation with a power screeder until the concrete was set up to the proper firmness for him to be able to walk on it. And they're using a combination of power tools and the good old hand tools, guys down on their knees, finishing it off with floats and edging trowels. There's a lot of work. It takes a lot of manpower. Let's go up to the garage where they're about to start pouring the floor up there. Now the material going down here in the garage is the exact same concrete mix that went down in the basement in the back of the house. And we're doing our pour in here, and you can see how many guys we've got working to get this out. Time is money with concrete, of course. You got to get the material spread out. You got to have the manpower. Now the pour is obviously contained within the walls here. Now, you'll notice that down on the floor here, where you would normally see rebar or a reinforcing mesh, a screen, there is none. And this concrete contains this fiber reinforcing right in it. Now, they gave me a brochure describing the fiber, and I got to read it to you because I'll never remember this. This stuff has 100% virgin homopolymer polypropylene multi-filament fibers containing no reprocessed olefin. It's got stuff in it that serves the same purpose. These guys find it funny, too. It's got the fiber in it, the exact same purpose as the metal reinforcing mesh, but it's all one unit contained in here. They'll screed it out, and this will be a beautiful flat surface when they're finished. Now, electrical in this house is going to be a little different. Now, parts of the house are conventional framing, like the 2x6 walls here. And with conventional electrical, of course, you use these great plastic boxes. You drive them into the wall. You punch out the knockouts. You run your cable up along here. You staple your cables to the studs, and off you go. Now, in this house, with the styrofoam walls inside, it's a little bit different process. Now, we're working with Keith, who's our electrician on site. Keith, how's it going?
Good.
Now, tell us about what we're doing different in here that you do in a conventional framed house.
Well, basically, you got to make yourself a channel through the foam. We do that by burning it out with the heat gun. There are several different ways you can do it, but that's probably the neatest and
let me see the tool, because that's
easiest.
That's an interesting tool here, a heat gun.
Just heats up and burns the foam through. You can pull it right out, as you can see I did a little bit here.
Right. Now, like a soldering iron, this whole element here is hot.
Exactly.
And that'll melt through the styrofoam?
Exactly.
Can we see you
Sure.
do it? What are you going to do first? You're going to...
I got to put an outlet here.
Okay.
I'm going to mark the height and then channel it. We basically use 15 inches as a standard for the bottom of the box. So your box will be in this area.
Right, okay.
Basically, I'm just going to channel down the wall and make a groove for the wire. You should go back as deep as you can to protect the wire more. Just slowly.
You want the wire sitting pretty deep in the wall,
exactly.
Right?
That way, you know, if anybody hangs a picture or something, they're not likely to drive a nail or screw into the wire.
Sure. And what you're left with, then, is the cutout parts, creating a little channel here.
Right.
Now, for cutting out our box, we have a different hot knife, but the same sort of deal here. Kind of, again, like the soldering iron model. The element this time is wider and rectangular. and that will cut out a hole just the right
Same
size. Here, Keith, we can see that it'll fit the box, so I'll let you
Alrighty.
have at it.
Need a little bit of room on top to get the wire in, so you want to make it slightly longer.
Right, so you're a little higher than the box itself. So then you'll come back out of the bottom.
Out.
Look at that, little plug will come right out of there.
Basically, we're just using a ramset gun.
Okay, this is a powder-actuated nailer. Uses a little gunpowder charge
Exactly.
to drive the fastener into concrete.
Fastener, right.
All right.
And it is a little loud, but it works rather well. Should try and make sure it's straight.
Now up top here, Keith is going to fit the wire into the channel, and we'll come down from up above down to our box down here. Now to keep the wire sitting back in the channel all the way back against the concrete in there, Keith is shoving little pieces of styrofoam that we cut with the hot knife every so many inches. Again, keep in mind we want that wire back against the concrete deep in the channel so it's not pierced from the outside when you're putting in nails or screws at some point in the future. Then we'll just feed the wire down here into the box because we've already got the knockout out. It'll come down here, and then we'll tighten up with a cable clamp and secure this into position. And then we're on to the next box in the circuit, up and over to farther down the wall. And we'll do the same procedure again, cutting down with the hot knife to create a channel, cut out a hole for the box, and put our next outlet in.
When the homeowner saw the position of this window, as it was planned in the plans, but you can't always tell what it's going to look like compared to, say, this window, which is a bit lower, they were worried that they wouldn't see the view. So they asked the contractor if he could cut it out and make it bigger, and yes, he can. Because today, we have the technology. And this is what we call an animal in the trade. It's a big disc cutter, and it's gas-powered. And over here, we have a diamond disc. There's commercial diamonds actually inlaid in the edge of this disc, and that's really the only thing that will go through concrete of this magnitude. So we're going to knock this piece of frame off of there. I'd already loosened that. Usually it would be stuck in the concrete, but I loosened it. And then we removed all the styrofoam from around here, and this is where we're going to make the cut, and Roy is going to help me with this. It looks like we're most of the way through, so what we're going to do is, rather than labor with the tool too much, is give it a hit with the bar and see if it'll go over. Oh. Are you ready? Let's send it over. Check down below. Can we check down below? There's nobody there. Well, as you can see, that wasn't too difficult. With modern technology, you can not let concrete walls intimidate you, and you can cut them. And now the homeowner has that beautiful view.
This is a beautiful location. You can certainly see why our homeowners wanted to settle down here. And this creek is only a couple hundred yards away from the house.
It's a gorgeous spot, and it's a beautiful day today, but it was the thought of potential bad weather that certainly drove one of the main choices in the decision of how to build this house. Keep in mind, one of our homeowners, Bob, is a TV weatherman. Now, he's going to be thinking more about the weather than you or I, perhaps. And even though Baltimore isn't exactly known as a hurricane center, they certainly are ready for whatever weather comes their way.
This is a really unique house. I don't think we've ever seen this before. A house made of concrete.
We did also discover that it's more than just dumping the concrete into the hollow forms. You've got to make sure that the concrete flows smoothly throughout the house. You don't want to end up with a void or a hollow area in the wall. That would end up being a weak section.
And putting in the rough window framing was a snap, as I saw you do. And, you know, it's different from conventional window framing in that you don't need a header. So it went in there really nicely, and then we poured in the concrete. Once that's set up, we were ready to put our windows in, and they went in pretty easily.
The vast majority of the construction design and style here is probably more of what we're going to begin to see in those areas of the country where they get a lot of hurricanes. We'll just have to wait and see.
Well, we're out of time, and we're off to find our next house, and we hope to see you there.
Right here on Gimme Shelter.
Bye-bye.